We want to convert the following fractions to decimals. And there are two main ways of doing this. If we can look at the fraction and write an equivalent fraction with a denominator that's a power of 10, like 10, 100, or 1,000, then we can just convert it to a decimal using place value. Otherwise, we'll treat the fraction as a division problem. So looking at the first example, we have 3 and 3/20ths. And if we recognize that if we multiply the denominator by 5, we would have 100, which is a power of 10. It will save us quite a bit of time. But of course, we must also do the same to the numerator to keep the fractions equivalent. So this is equivalent to 3 and 1500ths. So now if we know place values, we should be able to write this as a decimal, which would be 3, and 1500ths would be just 0.15. If we didn't recognize this, what we'd first have to do is recognize it's going to be 3 point something, and then convert 3/20ths to a decimal by performing division. Since the fraction bar represents division, this would be 3 divided by 20. And now what we can do is put a decimal point to the right of 3, move it up into our quotient, and then add zeros to the right as needed without changing the value of 3. So notice how in this current form, there aren't any 20s in 3, so we'd have to add a 0 here. And now I can ask how many 20s are on 30. That would be 1. 1 times 20 is 20. We would subtract. This would be 10. Add another 0 and bring it down. Now we have 100. Now we want to know how many 20s are on 100, which is 5. 5 times 20 is 100. And now this difference is 0, which means the decimal terminates. And notice how the decimal part here is exactly what we had above for 3.15. We just need to be careful not to forget about the whole number here to the left of the decimal point. Looking at the second example, if we can't think of an easy way to convert the denominator to a power of 10, we should go straight to division. 5/16 means 5 divided by 16. So again, we'll put our decimal point to the right of 5 and move it up into our quotient. And now we can add zeros to the right as needed. So if we put a 0 here, we can ask how many 16s there are on 50. That would be 3. 3 times 16 is 48. We subtract. This difference would be 2. Add another 0, bring it down. Now we want to know how many 16s are on 20. That would be 1. 1 times 16 is 16. Subtract. This would be 4. Add another 0. Bring it down. And now we want to know how many 16s are on 40. That would be 2. 2 times 16 is 32. Subtract, that's 8. Add another 0 and bring it down. Now we want to know how many 16s there are on 80. That's good because there's exactly 5 16s in 80. 5 times 16 is 80. And now when we subtract, the difference is 0, which means this decimal terminates. And 5/16 is equal to 0.3125. And this might be a good one to check on the calculator. We just need to type in 5 divided by 16. And this does verify our answer. It is common that when a decimal is less than 1 to put a 0 in the ones place value. Next, we'll take a look at two examples when the decimal doesn't terminate, but it repeats.